Hi learners, welcome back to DHILK. In this video, we are going to understand why aldehydes are more reactive than ketones. So make sure you watch till the end. After this, you won't be confused about this concept again. Alright, let's get started. So before we go into this reason, we have to know that in both aldehydes and ketones, there is a carbonyl group, right? Carbonyl group is nothing but carbon-oxygen double bond and two extra bonds. So the carbonyl carbon is electrophilic because the oxygen atom pulls electron density towards it, making the carbon partially positive. So you can see here the carbon atom, it has a partial positive charge and oxygen atom has a partial negative charge. It is because of the high electronegativity of the oxygen atom. Because of the electronegativity difference between carbon and oxygen atom, the shared electron pairs will be pulled towards the oxygen atom and they have a electronegativity difference and they are polar molecules. So carbonyl compounds are polar molecules. So because of this reason, oxygen atom will have a partial negative charge and carbon atom will have a partial positive charge. Okay. So now based on this, we can say aldehydes are more reactive than ketones because of two reasons. First one is electronic effect and second one is steric effect. Now we can check what is electronic effect and what is steric effect. Okay. So what is the difference between aldehyde and ketones? In aldehydes, the carbonyl carbon is attached to hydrogen atom at another carbon atom, while in ketones, the carbonyl carbon is attached to both of this bond is attached to a carbon atoms, okay, and hydrocarbon part, alkyl groups, okay. So in aldehyde, there is only one alkyl group and one hydrogen atom, but in ketone, there are two alkyl groups. So alkyl groups show a plus I effect. Alkyl group has a plus I effect, which means they donate electron density towards the carbonyl carbon. Alkyl groups, because of this plus I effect, because of the inductive effect, they donate electron density towards the carbonyl carbon. Okay. Now in ketones, there are two alkyl groups. So both of this carbon atom, both of these alkyl groups will donate the electron density towards this carbonyl carbon. So now there is less electron donation in aldehydes while there is a greater electron donation in ketones compared to aldehyde. So the carbon remains more positive in aldehydes compared to ketones, right? Because of the electron density, when the alkyl group is donating the electron density, it is reducing the electrophilicity of carbon atom. Carbon atom is partially positive and oxygen is partially negative. So why this is partially positive? Because of the electronegative difference between carbon and oxygen. So while alkyl group is donating electron density towards this positively charged carbonyl carbon, it will become less electrophilic, right? But in case of ketones, there are two alkyl groups attached and it will donate more electron density towards the carbonyl carbon and it will become less electrophilic. Okay, so it becomes less electrophilic means the chance of attacking of nucleophile is less compared to aldehydes. Okay, that is electronic effect. Now what is steric effect? It is steric hindrance. In ketones there are two bulkyl alkyl groups, but in aldehydes there is only one alkyl groups. Another one is an hydrogen atom. So because of the bulkiness of the alkyl groups in ketones, the attack of nucleophile become difficult. While in aldehydes, one side is just an hydrogen, while the other one is an alkyl group. So nucleophile can come and attack easily compared to ketones. Okay. So basically, what does it mean? In aldehyde, they have less plus I effect because of only one alkyl group is present and carbon is more electrophilic and less steric hindrance because one side is just an hydrogen atom and so that it becomes more reactive. While in ketones they have more plus I effect because of the two alkyl groups present and carbon atom become less electrophilic because of this plus I effect of two alkyl groups and they become more steric hindrance because of the bulkiness of these two alkyl groups and as a result of that they are less reactive. So basically aldehydes are more reactive than ketones because of electronic and steric reasons. So make sure rewatch this video if needed, practice the concepts, get fully comfortable before moving on. If you are a class 11 or 12 NCERT student and want complete materials, notes, tips, tricks or live classes, one-on-one sessions, visit our website or contact us through the number. Check the description box or comment section for more details. If you found this helpful, don't forget to like, share and subscribe and turn on the notification bell. Thank you for watching. See you in the next video.